slideshow.
Good. Oh yeah, thanks for having me. I'm really pleased to be here, and yeah, hopefully we'll have a good chat today about some options for foundations for buildings that don't or involve concrete or can reduce the amount of concrete we're using in foundations. Yeah, so a little bit about me. So yeah, I am a structural engineer working at Build Collective in Bristol. Let me see if I can move my slides on. Here we go. Here's a little picture of some of the stuff we do. So we specialize in low energy and low carbon design. So we're doing a lot of PassivHaus projects, a lot of retrofits. That's sort of our bread and butter. And then doing some slightly more unusual things like staircases and gardens for the flower shows and all of those kind of things. Just the sort of weird and wonderful is what we like to do. So I've done about sort of 15, 20 PassivHaus and ACB building standards and low energy buildings nowadays. So yeah, we're getting into the swing of things with that type of construction. Obviously doing a lot of timber construction in the above ground structures, and yeah, trying to minimize concrete use and lower our carbon in our designs, whichever project we're working on. Yeah, so today we will be looking at some options for concrete free and low concrete options for foundations. I'm going to separate them into, we've got shallow foundations, which are generally defined as less than 2 meters below ground level, and then deep foundations, which most people know as piles, which are greater than 2 meters below ground level. There's somebody that isn't muted, I think, unless I'm getting feedback from myself.
Okay, I'll mute them.
And then if we got time, we'll have a quick look at some ground improvement options, which are sort of sit between those two extremes. First of all, and sorry if I'm teaching some of you to suck eggs, we want to start with like defining what a foundation is and does and how that performs as a structure, and how we then decide on what foundation types we're going to use for any given structure. So we've got our little PassivHaus building here, obviously, and what does our foundation need to do? So first of all, our foundation needs to transfer all of the loads from our above ground structure into the ground. That is obviously vertically downwards loading, materials, snow, anything like that, people in your building. Those are the sort of common ones that most people know about. We've also got horizontal loads, wind loading being the primary one of those. They need to be transferred into the ground. We also might have uplift forces, particularly if we're dealing with timber frame structures or things with like large canopy roofs, flat roofs. We might get significant uplift forces on our building, so we need to again transfer those into the ground by anchoring our building into the ground. So that's, and then every action has an equal and opposite reaction, and those need to be dealt with in our ground conditions. So in order to know how we choose a foundation and how we design a foundation, we need to know a couple of things. We need to know what those loads are from the above ground structure, the superstructure, and then we also need to know what our capacity of our ground is, that in order that it can take those loads and spread them into the ground. So what do we need to, so how do we do this in terms of choosing a foundation solution? This is an example of a loading diagram that I've done for for somebody else designing the foundations on a project. So we would do a diagram like this, and we would show the magnitude and the location and the extent of any loadings. We would show whether they're area loads spread over obviously over an area, whether they're line loads like walls, whether they're point loads like columns. We also want to know what any kind of allowable deflections are in the above ground structure. I'll get into that a little bit more when we're looking at different types of foundation system, but some structures will tolerate more movement than others. For example, timber frame with like a timber cladding will accept more deflections than a stone, like a dressed stone finish building, because your stone will crack and it'll be obvious. Whereas a timber frame, it'll just move with the deflection. So that can be something that factors into your choice of foundation as well.
Beth, sorry, just one thing. There are some great we can see grey boxes on the presentation. So on the right-hand side, there's
Oh
it's
no.
greyed out. I don't know whether that's part of your template or whether that's something
So you can't see the pictures.
we can see. We can see 3/4 of your.
How is it? Does that help if I move that? All right. Is that better?
Let's move down to the bottom now. If you,
Ah, that's my little zoom. That's where I've got. I'll tell you what. I'll minimize that, and then is that better?
yeah, if you can just, yeah, that's perfect. Thanks.
Yeah.
All right,
Yeah,
brilliant.
that's my little zoom thing where I could see your face, but
Oh, right. Okay. Okay.
I'll forego that. So
Brilliant.
I just
Thanks, Beth.
imagine what you all look like. Yeah, so good. So there's a more complete picture of what a loading diagram might look like. And in geotechnical considerations, so this is a screenshot from the British Geological Survey of the area that I work in. So that's Bath in the center of that screenshot. So you can see there's lots of different colors going on. I've also stuck on that map things like landslip deposits, coal fields, all of that kind of stuff. So you can start to see that even in a small area, and that is literally just showing the city of Bath, and there's quite a variation in ground conditions even in such a small area. So we definitely recommend for anything over like a domestic extension, particularly if you're going for sort of new build house scale of projects, that you're getting a geotechnical site investigation for your specific site, or at least talking to a local geotechnical engineer who might know about the geology of your local area. As a quote from the Institute of Civil Engineers, there was, you pay for a site investigation whether you have one or not, because you just know a lot more. You have more certainty in your costs, in your foundation designs, all of that kind of stuff, by having a good site investigation. So we definitely recommend getting one of those done. Whether it's trial pits or boreholes will depend on what type of foundation you're doing, but getting some specialist advice on that. And also I'd say particularly if you're wanting to do something that is maybe pushing the norms in terms of reducing concrete in the foundations, you definitely want to be getting good information on your local geology. So just to explain some little diagrams that I've got going through this talk, this is looking at what we might be considering when we're looking at the geotechnical considerations on our site. We've got a few different types of soil there down the side. I've just sort of grouped these into quite generic categories. We've got obviously rock, large lumps of soil that is cohesive together. We've got then granular soils, which is generally gravels, sands, silts to some extent, and then we've got cohesive soils, which is clays predominantly, and then you'll see those images coming through the talk we go on. And then a couple of other considerations, whether you've got any large trees nearby, so that particularly will come into effect if you've got cohesive soils and clays, whether your foundation depth is going to be critical and the clay heave is going to be critical, and then whether you've got any buildings, particularly masonry buildings, near your site, that might also impact what types of foundation you can use. There are other considerations that will come into effect. So whether you've got contamination on a site, whether you've got slope instability issues, landslip materials, made ground, quarrying, mining, all those kind of things, but they'll all come out of a geotechnical site investigation. Yeah, so like I said, this is our little local area and all the different types of materials. So we've got rocks on the tops of the hillsides around Bath. We've got sands and gravels in the river beds. We've got clays on the side of the hills. Those clays in our area are particularly unstable. So we've got a lot of landslip material. That's the black hatch there. And then in Bristol, you can start to see the coal fields starting on the right hand side of on the left hand side of the picture there. So yeah, lots of things going on in a very small area. So it's something that we need to know about before we think about designing foundations. Yeah, so like I said at the start, we're going to separate the actual foundation types into two. We're going to do shallow foundations, which are less than 2 meters below ground level, and then deep foundations, which would be greater than that. Yeah, so that's generally how you sort of split the foundation decisions as a general rule. So starting with shallow foundations, Most of the, obviously, in generic terms, this would be sort of concrete strip foundations, that kind of thing. It will strip or trench foundations, pad foundations, that kind of thing. They can be reinforced or unreinforced. That's a sort of generic type of foundation. So yeah, looking at some options as to what we might do as an alternative to those type of concrete foundations at a shallow depth. So starting from the sort of most historical perspective, we've obviously got masonry spread foundations. This is what a lot of traditional buildings, well, I mean, a lot of our building stock is actually founded on. We've got the masonry walls going below ground, and then they might spread out a little bit just to give a bit of a wider bearing area underneath the wall. They might not, they might just keep going the same width all the way down. And then that just sits on the ground, whatever that happens to be. It could be anything: rock, gravels, sands, clays, anything like that. You can, as long as you've got a good bearing capacity, you can do a masonry spread foundation. What you struggle with, obviously, with this type of construction is getting very deep, because it gets unsafe to dig a hole and then also to lay masonry units in that hole without sort of really carefully considering shuttering the sides of that excavation. So you might not be able to use that on a site that had significant trees, for example. But you'd be wanting to look for, if this was an option, that your ground, whatever type of ground it was, had good bearing capacity, because you're not going to be able to spread that load over a massive area. Whilst you can corbel like these pictures show, you're not going to be able to corbel to the extent that you might be able to do, say, a concrete foundation width. You also don't have any uplift capacity, so it gets, which is true of masonry generally, but also true of using masonry as a foundation. So you wouldn't want to be looking at this if you had any significant uplift loads. And also you would be wanting to minimize at least the size of the point loads that you're putting on this. Again, this is true of masonry generally, because you've got a sort of capacity that you can add a concentrated load to masonry. So yeah, you'd be wanting to minimize the point loads. So but that is an option, more traditional option. One that we get asked about a lot is using limecrete in the ground as an alternative. I mean, it's the most similar to concrete as an alternative, because it sort of flows and then it sets. So you could theoretically do a sort of something that was comparable to a concrete foundation in limecrete. You do again need good ground bearing capacity for this to work. Otherwise, you're sort of needing to get something that is really wide, and you can't reinforce it in the same way that you can do with a concrete foundation. It's good where the concrete strength doesn't govern the foundation design, which is true of most mass concrete foundations, but that's because you don't get the same hardening profiles in limecrete that you do in concrete. So you can't guarantee that it will be a certain strength at a certain time period from when you've cast it. So in concrete, that's often 28 days, but you can get a significant range in compressive strength at a 28-day period in limecrete, which you don't get so much of in concrete. And then because of that, you need to be really careful about curing limecrete and managing the moisture whilst it's curing. So it's just something to think about. It's not that it's a no-go, but it's just those considerations that you would want to make if you're thinking about using it. And then similarly, and something that some people use in conjunction with limecrete is compacted gravel fill. Again, you wanting a good ground bearing capacity. You might be able to use recycled materials from site. If it's a gravel site, you would wanting to be using something that was graded to the MOT highways spec, which does include site materials but it depends on what those existing materials are. Again, you don't have any uplift capacity in this type of foundation because it's not bonded together in any way. And you would want to think about what would happen if somebody were to dig down next to that gravel fill trench in future, for example, to build an extension onto your building that you had used this foundation type for, which is why in the picture here you've got a geotextile that is containing the fill, so that you've got some sort of temporary protection, at least if you were to dig down near it in the future. Yeah, that's an option. a way that you might give that compacted fill an uplift capacity would be to contain it in a car tire. This picture here shown has got a plate on the top that you can see, and then there's another plate underneath, and then you're activating that whole weight of fill material in that car tire to give you uplift capacity. This has become, I think, less popular than it potentially was sort of 10, 15 years ago, partly due to the waste criteria on the amount of, because car tires are generally described as waste when they come to site, and the amount of waste you can put on your site without it becoming effectively a landfill. So that's sort of, I think, what's limited its use recently. But yes, it's an option to use it as a sort of pad foundation alternative to a compacted fill trench, and you've got the option to make it give it some uplift capacity. And then similarly here, which is something that's more common, I think, in the States, is using baled car tires as a sort of ballast and fill material to build up site levels. I think they have used that in this country a little bit, but it's, again, like I say, because of the waste classification criteria, it's become less popular. Yeah, so that's, but it's yeah, something that to think about. This is another shallow foundation option that we see people asking about a lot. These sort of nail plates, I call them, and they sometimes they have scaffold tubes that you drive into the ground around this plate. The diagram there has just got bars going around, but that could be an option. These are obviously for point loads, so for frames. This one's obviously showing a steel frame. So they're good for sort of gravel materials, sands, gravels. Obviously, if you had rock very close to the surface, that wouldn't be a great option because you wouldn't be able to drive the nails into any depth. And you might, if you've got rock close to the surface, you might be looking at something more like a spread foundation at shallow depth. And then the other consideration with these is if you've got clays with significant volume change potential or significant trees nearby, these don't have any capacity for allowing the volume change of the clays to not affect your structure. So yeah, they to be honest, I get a lot of inquiries about these and never have actually used them because there are more common methods that are similar enough, like screw piles, that they haven't actually taken off on anything but that I've done, but they are an option. And then just a question mark here about what timber options that we have seen. We've done a little bit of, so using timber spreader ground beams, maybe on top of like a compacted fill trench. We've done a little bit of that. You obviously do have to consider the specification of that timber, that it's durable enough to be in the ground. CLT rafts, I've seen particularly American commentators looking at that. If you want some more information, there's a really good YouTube video by the Building Science and Beer show on YouTube, and they did a session on concrete-free slabs. They was mainly talking about ground floor slabs, but they were also talking about sort of basement slabs. So that was interesting. But yeah, just a sort of food for thought there on that as a end to the shallow foundations. I'm just checking how much time we've got. I might come back to the ground improvement techniques if we've got time at the end. Maybe I'll just quickly gloss over those now. But so an option for larger sites where you might be looking at taking a site from a site that required piled foundations to something that could use shallow foundations on our ground improvement techniques. They are quite cost effective and readily available. You've got a few different options. You've got vibro compaction, which is for granular soils where you compact the existing soil on site in sort of little columns, basically in the ground, into something that gives you a greater bearing capacity at those column locations. And then you design a raft slab to go over or a foundation to go between those little columns in the ground. The similar option for clay sites is to use an imported material in your little columns to make a little stone column in the ground, and that's fibro stone columns. That's like I say, for clay sites. And then also for clay sites, there's lime stabilization, where you rotate basically lime into the clays, and then it hardens over time. And then you can take a site that potentially needed piling and put a shallower foundation on it. And you basically just design your stabilization system for whatever loads you're wanting to put onto the site. Yep, so those are some options. Maybe using geotextiles underneath a raft foundation, for example, to give an extra strength to make a shallow foundation suitable. And then we're moving on to deep foundations, which is probably what most of you have come here wanting to talk about, which is essentially piles. And there are other deep foundation options, but most people are talking about piles when they're talking about deep foundations. So we'll start from the most common, and then we'll get into some other options. Yeah, so steel screw piles, which is like if people come to me wanting to do concrete-free foundations, they're generally wanting to do screw piles, which are like an option. So you with a screw pile that has it's got a thread on it, so you need less pile length to achieve the same capacity that you would do for a sort of fully friction pile driven into the ground. They come in one length, so they come in the design length that you need them to be on the site, and you can get them up to sort of 6-8 meters, depending on what you're loading and what your ground conditions are. There is a question around how they deal with clay heave. You do need, if you have a clay heave issue, you do need to be careful that you're not engaging the pile over the top section of the clay where it has the most heave potential. The way you would traditionally deal with that in piles is to put a debonding sleeve on that top section of your pile. I don't see a lot of screw pile manufacturers doing that. I would say that there are a couple of different genres of screw pile manufacturer. There are the really sort of small domestic ones, which are mainly for putting up sheds, but they're the screw piles that actually look like just large wood screws, and they generally come around about sort of 2-3 meters in length at a maximum, and they are definitely for the sort of less habitable type of spaces, so like your garden rooms, your sheds, that kind of thing, your pergolas. And then you've got the sort of more official screw pile manufacturers, because you can there are screw pile manufacturers which have been used on things like highways and railways projects, so you can get ones that are like properly that have official design criteria and processes, and also come in the much longer lengths and the much greater capacity. So you've got a few different options there. Looking at that, you do need to make sure that you don't have rock really close to the surface. I had quite a few inquiries a few years ago where they wanted to use screw piles, and then we did a site investigation and realized that there was rock 300 millimeters below the ground level, so we weren't using screw piles. And then you can look at other shallow foundation options, but so don't get too set on a type of foundation before you've looked at what the ground conditions are. But yeah, so a question mark around the use of them near trees in clay heave potential sites. But yeah, they're a good option. There's quite a few manufacturers available nowadays. If you're wanting something with a sort of for a house type of project, look for manufacturers where they've been used on railways and highways projects, because they'll be the sort of better capacities. And yeah, so that's the screw piles. Another option, which I quite like, are ductile iron piles. These are a driven pile, and they come in 5-meter lengths, and then but you can extend them in sections, but because they are driven piles, and the one section drives into the other, and then you just extend your pile length to whatever you need it to be. They're low vibration installation whilst they are a driven pile, so you can install them quite close to existing masonry buildings, which a lot of driven piles you can't. You can also, they're hollow tubes generally, but you can fill them with grout and put a bar down the center if you need some moment capacity from them. There is a question around, there aren't a lot of installers for them, so sort of getting availability and getting a good price on somebody who can install them is a little bit tricky sometimes. But they're a good mini pile option. They've got a really long design life. Yeah, they're from a design perspective, they're a bit more flexible than a screw pile, particularly because you can really get the decent lengths on them, sort of 25, 30 meters if you need to. So yeah, there's an option there as a sort of longer length pile. You've also got just the standard steel driven piles. These are quite good for contaminated ground because often the tubes they're using are recycled tubes from the oil and gas industry, so they're quite high grade steel compared to most structural steel. So they're good for contaminated sites or sites where you've got particularly unstable ground. Sorry, I'm just going to have a drink of water whilst I lose my voice. Like I said on the ductile iron slide, you wouldn't want to be using these next to existing, particularly masonry buildings, because they are a high vibration installation. And they also come to site in the length that you need the pile to be. So you need decent access to your site in order to, if you need a decent pile length, you need decent access to be able to get the tubes in one piece. Timber piles, it's an option, been used historically for a long time. Obviously, Venice is a good example of a city on timber piles. So yeah, they're a driven installation, and obviously they come in the length because you can't joint them together. So they come in the length that you need your pile to be. So that's a question around how you would source your timber, particularly if you're needing something, say, over sort of 3-ish meters, which is a sort of standard timber length in this country. Where you're sourcing your timber from could be an issue. You've then got once if your timber is in the ground and in water, it's the risk of rotting is minimal, but it's that junction between the air and the water, or the air and the ground, that is the critical point for timber design. So thinking about how you will protect your timber in that junction, you might use a local section of concrete just to protect that joint, or steel, or there's lots of other ways to deal with that, but that's going to be the critical point. And that's what this picture was, a bird hide that I was surveying, and that was the section of the timber that had rotten in that junction between the ground. You can see that in the ground it's fine, but where you start to get out of the ground, you start to see there's rot in that connection. And also that on that one, the timber connections were with the superstructure quite close to the ground level. So that was but so that's been used. So you couldn't use that near neighboring buildings because you've got a lot of vibration on the installation, but it's something that could be looked into for really looking to reduce the embodied carbon in your project. And then to finish, before we get on to some questions, something else to think about is if you do have existing foundations on your site, maybe you can reuse those. There's a guide for this BRE guide is particularly for existing pile foundations in urban sites, but you've also got the more common option that we come across is people wanting to use the existing strip foundations from an existing building for the new project. It's something to consider on this is if you're reusing the foundations that were designed for a certain loading arrangement and loading type, you would want to be keeping your loading from your new superstructure very similar to what your loading profile was on the original building. The main thing is when you're using is you're not wanting to introduce significant point loads into your foundations where there weren't point loads in the first place. That's particularly true for strip foundations, because you might then end up needing to underpin or widen the foundations locally, or just replace the foundations locally with a new foundation. So if you're wanting to use them as much as possible as they are existing and not edit them too much, you want to keep the loading profile similar to what your original structure was. So I think that's about it from now. Little summary there, things that you would want to know initially in order to choose your foundation type. You want to know the loading from your above ground structure, and you want to know your ground conditions and what its capacities are. And then you can start to decide whether you're going to look at a shallow foundation or a deep foundation, and then you can start to disseminate your options there. But yes, hopefully we've got some decent time for questions now.
No, thank you very much, Beth. It's fantastic. Is it possible just to share that presentation with me, and then I'll upload it?
Oh yes,
if that's okay. I know not everyone's able to do that, but there's a hell of a lot of information, very practical and useful information there. Robert, would you like to come off mute and just ask your question?
Hi there.
Oh yeah.
Yes, the timber piles, interesting. Interested in that, and wondered about your advice for architects detailing the head of that, whether it needs to be encased in concrete, steel, plastic, something like that. Is there a standard detail or recommended approach?
Not a standard detail, would depend a lot on what your above ground structure is. I've seen people do encasing it in, well, in some kind of bituminous painted system, basically, concrete toppers. I've seen people, there was a company that I looked at that were doing a really good sort of precast concrete topper that came sort of ready fitted to your timber pile, but I'm not sure how around that is available. That's the thing with timber piles, is the availability. But yeah, it would depend, yeah, a lot on your ground conditions, on what your superstructure is. But yeah, there's a few options. All of those that you listed there, basically steel, concrete, some sort of paint-on system, some other timber connection.
And Robert, what's your discipline? Are you an architect or?
Architect, yeah.
Oh, you are. Okay. And sort of what's driving your questions here then? Is it because people are coming to you and they're looking to decarbonize their particular project, or is it something that you push? And how does that conversation with the client go?
Yeah. I think it's something we push, and I want to be as knowledgeable as possible for the inevitable questions. But also just I like to think about how that would detail out to avoid obviously the drawbacks.
No.
I mean, just thinking about that, obviously, if you're taking Venice as an example, that is masonry. So that timber piles come up into a little masonry spreader, and then they go up in obviously masonry in that instance. So there's lots of different options there.
Thank you.
Well, thanks for the question, Robert. Thank you. And then, Beth, when it comes to, sort of why you're having these conversations, how you're having these conversations with either sort of the developers or house builders, etc., or homeowners, conversation to Robert, how do you get involved in sort of, how can I say, sort of non-green building solutions? Obviously concrete. I mean, how much of your work is through looking at alternatives and compared to concrete? And I'm assuming that you guys are ahead of the game, and because you're sort of highly regarded in this space and you've got your personal connections with the AECB, there's probably not many structural engineers are as well informed as you guys are. And sort of, so as a proportion of the market, or how common are, screw piles, for instance, compared to, should we be using more? I know we should be using them more, but could we be using them more than we are currently? What's stopping the adoption?
So I guess sort of from our perspective, we are trying to, on all of our projects, regardless of whether they sort of come in as low energy or low carbon projects, we're trying to give a good option in terms of material usage, particularly from our perspective when we do our designs. So there have been projects recently that didn't come in as specifically low carbon projects, where we've there's been one interesting one recently, which was screw piles, and then we ended up using a timber deck on top of the screw piles for the floor, for the ground floor, as opposed to like a beam and block or a steel option. So yeah, we used timber glulam ground beams, a glulam deck. It was a composite glulam and then a very slim concrete topping floor. So that one was quite interesting. Yeah, so we're trying to often the cost is the limiting factor. So if you're looking at something that isn't, like I said, the really domestic shed type of screw piles, they can get quite expensive, particularly compared to other types of piling. So we've had a couple of projects recently where the site needed to be piled anyway, and then they were like, oh great, so we'll use screw piles. Okay, great, yeah, so that sounds good. But then they were double the cost of a concrete pile. So then both projects, they've ended up going for a concrete pile of various different types. So yeah, that was a big consideration.
Well, yeah, I mean, that's not surprising. A few more questions here. Beth, again, I don't know, there's a big block in front of your presentation. I can either stop sharing the screen or we can, I don't know if you've got a...
I kept it up just in case anyone wanted me to flick back to it, but I can always just get
sure,
rid of
but
it.
what I'm saying is one of these grey
Yeah, it's because I've put my thing up so I can see your face. Yeah.
Oh, right.
I'll move it down here.
Understand. Fine.
Yeah.
And again, if you have an end slide with your contact details, if you specifically wanted to show that, then you could put that up there. But now we can see the slide now anyway. Thank you. AJA, sorry, I don't know your name. Question here: have you come across dense plastics / composite materials for piles and ground beams? They are not quite as strong as steel, but they can have bigger sections and they do not rot or corrode.
Yeah, I mean, you can do sections of like glass reinforced polymer but you can get sort of similar sections shapes to steel I-beams and angles and that kind of thing. It's not something I've used ever. We're not in that way. We've used glass reinforced polymer angles for like low thermal bridge details to support like large sliding doors, but that was on concrete foundations. So not something we've done a lot, but they do exist. It's the availability and the cost generally. So because we're doing like commercially so obviously my work is sort of in practice, so it's not research based. So we're doing stuff that has to be built by somebody and be afforded by somebody. I'm tending to do stuff that is more of the commercially available stuff than, like I say, those things exist. I haven't used them a lot. But yeah.
No, understand. And the guys from Mitchell Evans, did you want to come off mute and ask your question?
Yeah, hi there. Thanks. Thanks, Beth. Sorry, I'm not sure if I maybe I just missed something here, perhaps. But can you explain what you build up on top of the gravel fill footings? Because the image and the description was just very much sort of almost like a loose gravel fill in a trench. But what goes above that?
Yeah. So actually, on this project, I'll go back. Click through. Actually, on this on these photos, so the gravel fill trench there and the limecrete are from the same project. So that's actually a limecrete topper with a gravel fill trench beneath. So that's an option for that. We've done other ones where people have just built masonry off the gravel fill. Sometimes with a little bit of sort of either like a slurry leveling mix on the top of it or sand cement mix to give you a level starting point for building masonry off that. Or we've done ones where we've done timber ground beams on that gravel fill trench and then built, I think that one was timber then off the top of that. It might be masonry, can't remember. But yeah, so a few different options of materials that you could do on the top. But yeah, so that the most common one I'd see is a leveling compound of either concrete or limecrete on the top of the gravel fill trench.
Okay, cool. Thank you.
Cool. Cheers, guys. And I think Sarah was asking for a similar sort of explanation for limecrete.
How you would build up off that?
Yeah, is that right, Sarah? It came straight after the Mitchell Evans question talking about.
I think I just a little bit of information. So I understand that the limecrete, I think it was about the hardening of the limecrete. What's the issue? You need longer for it to gain strength, or?
It's not necessarily that you need longer even. Some of them just never achieve the same strength. So with concrete, you get hardening curves which show you for each grade of concrete exactly what strength it's going to meet at different times during its curing. I can't remember how long they extend to, sort of a few months, but yeah, 28 days is usually the critical one that we deal with. But so on that example there, so the NHL 5 mix is supposed to be 5 newtons per millimeter squared compressive strength at 28 days, but they've actually shown that in reality it can vary anywhere from 1.5 to 9, and a sort of a generic mix for a concrete foundation is usually sort of around 15-20, and it's not necessarily that it needs to be that strength, but we know that at 28 days it is going to be 15 or 20 within a very small margin. given that it's got the certain water content and sand cement ratio in it, whereas the limecrete mixes can just vary widely, and depending on how, mainly on how much water you've put in it, but just like the temperature and on all of those kind of things. So you need that to not be a critical design criteria, basically, the compressive strength that you're trying to achieve, if you want to use it in that way.
Okay, thanks.
Okay, Sarah. Lucy's asking, what category would product like Rapid Root fall into, and what ground conditions can it be used on? Is that something?
Yeah, those are I think those are these things basically. But I think the Rapid Root ones are the ones that have, rather than just the bars that picture has, they've got scaffold tubes, effectively, like sort of hollow tubes that they drive into the ground around. Yeah, so this is the category that I put them in, sort of soil nail plates. Yeah.
Cool, thank you. And then you said earlier on about the need for geotechnical site investigations. I presume when it comes to insurance and PI and everything you do is going to be governed by your policies. So do you always insist on these? I mean, in terms of that quote that you had right at the start, you pay for one whether you undertake one or not. And what's the process there? And when people come to you with certain suggestions, you said you have to be open to the ground conditions. How much do you lead them, or how often is it that you end up doing something that the client initially is looking for?
It depends. It depends on what they came asking for. Often, so for the more common example, a lot of people want to do, when I do PassivHaus projects, they want to do insulated raft foundations, which are a really versatile foundation type because they're designed to deal with variable ground conditions. That's what a raft is useful for. So those, if we were looking at foundation types generally, when people come with wanting to use screw piles, which is quite a common one, it's less common that they actually end up using that. So, and because usually they will have chosen that foundation type before they've looked at what the ground conditions are. And whilst the superstructure will have some impact on a pile foundation system, the main thing there is going to be the ground conditions. So, well, I forget what your original point was, but
I was just talking about how, in terms of obviously the indemnity insurance and how you sign off or accept, scope out a project based on, obviously, I imagine it's a lot of your job comes down to risk management, obviously, and how these buildings have got to be secure, and whether they're sustainably built or not. Sometimes it's not going to come into it. It's whether you've obviously got to ensure that the building does the job of the building.
Yeah, and I think that's what a lot of people don't necessarily appreciate about engineering, is that, yeah, like you say, we are effectively managing the risk, and I think particularly when I get people going, oh well, I've gone to this other engineer and they don't want to do that, and you're like, well, yeah, it's that, and it's a lot more. I've said this before, but I feel like it's more subjective. It's more, not necessarily that it's subjective. It's sort of like your personal opinion on it, how you as an engineer appreciate risk, more so than necessarily can you physically design the thing. I think because a lot of engineers, when we say no, you can't do it, it's often rarely that you can't, it's that often that you don't want to, take that risk on your PI, and that's, I think, something that I've grown to understand, particularly as I sort of developed in my career, is that it's a lot more like just based on a a feeling well, so on a feeling on your experience from other projects and on all of that and all of you, but it's less about exactly like the numbers, shall I say.
Yeah.
But yeah, but we do have sort of processes. So like I say, if it's a new build house, like a Grand Designs new build type of house, which is a lot of what we do, bespoke new build houses, will want a site investigation, a geotechnical engineer, usually, particularly if it's in our local area, because we know there's lots going on around here. It does slightly depend on where it is in the country, but yeah, we'll want somebody, if it's not that local to us, we might want to chat to a engineer, a geotechnical engineer who is local to the site, who might know more about any sort of local issues. Yeah, if it's a domestic extension, we might take a bit more of a view on it. But the other thing to consider is if you are using piles, you need a borehole to be able to design the piles in the first place, to give you data of the ground profile that you're going to be putting your pile into. So if you're wanting to do a piled foundation, you would need a borehole investigation anyway, so good to get those moving early on in the project so that you minimize the risk.
Yeah.
And
when it I mean, obviously you've presented, whether it be shallow or deeper foundations, a number of alternative solutions to concrete there. I mean, where do you go? I mean, you mentioned how you're on the commercial, you've obviously got to be commercially viable for Build Collective, but in terms of trying to source new ideas for alternative solutions, how do you do that? And are there new technologies coming through still now, or these? I mean, obviously these are the ones that you're aware of. I mean, where do you find your information from?
Yeah, there are like these nail plates are a sort of newish type of foundation. Yeah, there are still things, people developing different types of foundation coming through. The journals, the institution journals are often one of the things that I'm looking to, and then also related to that, our institution local events, because the Institution of Structural Engineers and the Institution of Civil Engineers, both of those have journals, and then they also have local events that are not just open to members. So if you want to go to any of those, and they generally have the local talks will obviously have local engineers talking about things that they're interested in, and so those kind of things. Yeah, it's a good question. Just chatting to other engineers, reviewing other projects, seeing which from my perspective in terms of working out sort of engineering systems and things, tends to be from the engineering journals, because I find that the architectural journals don't actually tell me enough about how it's actually standing up to be particularly what's going on in the ground, to know what was going on there. But yeah, so yeah, hearing other engineers do case studies. If you're interested in the sort of timber developments, Trada have done, or what have they called now, Timber Development UK, have done a series of webinars quite recently, and I know some of the engineers who did the presentations for those, and I know there were some case studies in those, and that involved timber foundations and timber piles, so they're a good shout.
Cool. We had those guys on not so long ago. If there are any, we have a couple of minutes, or well, actually we're literally nearly out of time. So if there's one more question, please ask. Otherwise, really much appreciate you taking the time to talk to us today, Beth. It's really interesting, really useful, very comprehensive amount of information there. So yeah, I'll share that with everyone. Oh, Jamie's just got in with one question. Beyond substituting aggregates within concrete, is there anything else that could be done to reduce the carbon loading? Sorry, messages are flicking up. Is there anything else that can be done to reduce the carbon loading on concrete foundations?
The main one that has more of an impact on carbon than changing the aggregates is reducing the cement content. And there's a couple of ways you can do that. The most simple way is to reduce the concrete grade that you need. So if you can work out a way that, particularly if you can minimize the number of point loads, for example, and you can go back to an unreinforced strip foundation that can be a lower grade concrete that has lower cement in it in the first place. And then you've also got the cement replacement options, pulverized fuel ash, and which is PFA, and granulated ground blast furnace slag, which is GGBS. And they, particularly GGBS, have a sort of, you can swap out a significant amount of the cement for those kind of things, and they have they're the sort of simplest like for like ish swaps that you can do. There's a whole question about the availability of GGBS and all of that kind of stuff, but from a sort of simple perspective, those are the two ways: reduce the concrete grade where possible, and swap out the cement.
So I read something earlier on hempcrete as well. Hemp seems to be like, again, I don't know enough, but hemp has so many uses, and I'm wondering whether is hempcrete going to be can it be usefully used to swap out concrete?
It's an odd one. I think it's a bit of a misnomer, because hempcrete is effectively just an insulation product. Because we've done quite a few hempcrete, and you can get the wet installed hempcrete and the blocks, but it's more of a masonry type of substitute and an insulation product than a concrete substitute.
Right.
Sort of
Okay.
Simple explanation. But yeah.
Cool. Well, I think everyone's really enjoyed that and found it very useful and informative. So yeah, thanks Beth. Yeah, much appreciated. Yeah, thanks to everyone else who joined the call. It's good, nice to have a good turnout as always. And yeah, we'll see you on a future call, i.e. next Wednesday. So yeah, thanks for everyone for attending, and I'll see you next week. And yeah, cheers Beth.
Thank you. All right.
Thanks guys.